Hello friends, and welcome to another episode of Find Your Einstein Friday. My name is Scientist Bond, Covalent Bond, and today I'm going to be sharing another super sweet science experiment. Did you have a celebratory corned beef and cabbage on Wednesday for St. Patty's Day? Or maybe you stuck to the corned beef and that cabbage is still sitting in your fridge. Well, either way, in today's experiment, cabbage is on the menu. We're going to learn about acids and bases with this experiment from Science Buddies called Cabbage Chemistry. Let's first talk about solutions, acids and bases. A solution is a type of mixture in which one substance has dissolved into another. Solutions are homogeneous, meaning they are evenly mixed throughout. Keep in mind, substances combined in a solution do not turn into new substances. Think about salt water or sugar dissolved in water. You can't see the salt or sugar, but it's there. Acids are solutions that give away hydrogen ions in a solution. They generally have a sour taste. Bases are solutions that take in hydrogen ions in a solution. They usually feel slippery. To determine if something is an acid or a base, you will use a chemical called an indicator. Indicators will change in color depending on whether a solution is acidic or basic. An indicator works by responding to the amount of hydrogen ions in a solution. There are many types of indicators, including the pigment of some plants, and that is what is going to help us in our experiment today. Welcome back, red cabbage. Red cabbage can act as an indicator because it contains a molecule called anthocyanin. If a solution is very acidic, it will turn anthocyanin a red color. If a solution is neutral, it will turn anthocyanin a purplish color. If a solution is basic, it will turn anthocyanin a greenish yellow or yellow color. Anthocyanin is also found in apple skin, red onion skin, poppies, blueberries, cornflowers, and grapes. In today's experiment, we will extract cabbage juice indicator and use it to discover whether some common household solutions are acids or bases. So let's get started. But as a reminder, as we can't be together in person, don't forget to have adult supervision. Let's first review our materials. You're going to need a small red cabbage or a bag of chopped red cabbage, a small food chopper or grater, or you may have to chop it with a knife. If you need to do that and you're not using the bag that's already pre-chopped, we do encourage that an adult does that for you. A tea kettle to boil your water, a strainer, small white Dixie cups, one for each household solution that you're going to be testing the pH of, a medicine dropper. If you don't have a dropper, one of these will work. Goggles if you are going to test household cleaning products, one pot and one additional large bowl or pot, and a lab notebook or a piece of paper because we're going to document our results, and we're going to also talk about what pH is going to come out of each color that we see. So a couple of helpful tips. Remember to have all your supplies ready before you start. Clear your surrounding surface area. Don't use strong household chemicals if you do not have goggles. Only test some household liquids like juices and other drinks. As mentioned before, you should have adult supervision. In this experiment, we recommend an adult to assist with cutting the cabbage and handling any boiling water. So first, you're going to grate or finely chop a small red cabbage or take out your bag of finely chopped cabbage. And you're going to put it in a pot or a bowl. As you can see here, I pre-did it, but I saved some to show you what it will look like. Then you're going to use your tea kettle to boil some water, and then you're going to pour boiling water into the bowl just enough to cover the cabbage. So if you were pouring it into this bowl, you wouldn't want to pour the water up to the top. You would want to pour it just enough to cover what's in here. Then you're going to leave it in the mixture and stir occasionally until it's room temperature. And you can see we have our room temperature cabbage here for you to see. What you're going to see at that point is the liquid should be a reddish purple in color. Now we're going to place our strainer over our second large pot or bowl. And I'm also going to use gloves because I don't want my hands to get really purple with this. But what we're going to do is we're going to pour the cabbage into the bowl so we can get all the cabbage pulp out and just have the liquid, because that's ultimately going to be our indicator solution. So as you can see, I'm pouring it in here nice and slowly so it doesn't splash. The indicator is going to help us determine the pH of the solutions we are testing. So what is pH? In chemistry, pH is a scale used to determine how acidic or basic a solution is. Acidic solutions are measured to have a lower pH than basic solutions have a higher pH. So we set aside our indicator solution. We're going to use this as a stock solution for our experiments. Now we're going to test our various household solutions with our indicator. We are going to use a separate Dixie cup for all of our solutions that we're testing. And we're also going to use a separate Dixie cup to put our solution in, our indicator in. So it says to fill about half of the Dixie cup with our Cabbage indicator solution. So I'm going to fill up 6 of these since I'm testing 6 different solutions. If you don't have enough solution, you can do a little bit less than half. Now I'm going to put my goggles on because I am going to be testing some household cleaners. And we're going to start by adding drops of liquid that we want to test to the solution and watch for the color. Once we drop it in the solution, we're going to gently swirl the cup as we add the drops, being careful not to spill the solution. We're then going to record the pH and a description of each solution in a data table in our lab notebook. So I'm going to start with the apple juice. So I'm going to start with my dropper here. I'm going to take in a little bit of apple juice. I'm going to grab one of our pH indicators, our Cabbage juice, and I'm going to put a couple of drops in. And I'm going to swirl it around, being careful not to put my face near the cup or to spill the indicator. And I'm watching for it to change color. And now I'm going to set this aside so we can look at the colors after and record what it looks like. So we have our apple juice. I'm going to have my helper here rinse out my dropper. Okay, now we have our orange juice. I'm going to take in a little bit of orange juice. And I'm going to pour some drops in our indicator solution. I'm going to swirl it around. I'm going to have my helper rinse out my dropper. I'm going to take in some Coca-Cola. And again, I'm going to drop it into our indicator solution. I'll do this one up here so you can see. Just a couple of drops. I'm going to swirl it around gently. We're going to rinse out our dropper. Put this aside. Now we're going to test out our vinegar. Grab another indicator solution. Taking in some vinegar. Again, dropping some into the solution. Swirl gently. Put it aside. Now we're going to test 2 household cleaners. We have Mr. Clean and we're going to do peroxide. So I'm grabbing my last 2 indicators, my last 2 solutions. First we're starting with Mr. Clean. And again, just a reminder, if you are testing household cleaners, you're going to throw this dropper out after. Do not reuse your dropper. Swirling. That's the darkest one we've had. Rinse it out one last time. Rinse it real good if you are doing household cleaners. Our peroxide. Dropping some in. And now we are going to look at our results. So this is where your lab notebook comes in. So what you want to do is we're going to use this chart here. So now we're going to talk about our results. So what you're going to do is you're going to write this table down. And I'm going to show it up close in case you want to pause the video. And each number is going to coordinate with a color that we see. And based on the number and the color will tell us where about the pH is of our solutions. So let's check it out. So let's start with our peroxide. So if you look at the peroxide, it actually stayed purple. So if we look at our table here, purple is a 4. So we're going to document that on there for the peroxide. It was purple and it's a 4. And now we know that colors lower on this pH scale are usually acidic. Now we are going to look at our Mr. Clean. Now this color is very interesting. This color is actually like a blue. So we're going to look at that here. And so when we look at our table, blue coordinates with the number 8. A number 8 is slightly over neutral. So this would lead us to believe that our Mr. Clean is basic. Now we're going to look at our vinegar. The vinegar is completely different than the Mr. Clean. So if we look at our vinegar is more of a really light purple, almost red actually. So I would say this is between a 2 and a 4. So this would lead us to believe that our vinegar is acidic. And I'm going to give it a 3. All right, now we're going to look at our Coca-Cola. Our Coca-Cola stayed almost the same color, so just regular purple. And again, back to our table. Purple is a number 4, leading us to believe that it is acidic. Two left to check. So we're going to check our orange juice. Same thing with the orange juice. The orange juice didn't change too much in color. It got a little bit lighter, but it is still on the purple side. So again, a 4. And let's look at our apple juice. And our apple juice did not change very much in color either. So again, we have purple, and purple is a 4, which would lead us to believe that the apple juice is also acidic. So out of all of the solutions we tested, it looks like only the Mr. Clean, which turned blue, was on the basic side. All of our other solutions were acidic. So here's a fun fact. Acids and bases neutralize each other. So that's why that antacid tablet that you might take for a stomachache or heartburn is a base. So here's some key takeaways. A solution is a type of mixture in which one substance has dissolved in another. Acids are solutions that give away hydrogen ions in a solution. They usually have a sour taste, which would make sense of why our orange juice ended up being acidic. Bases are solutions that take in hydrogen ions in the solution. They generally feel slippery. To determine if something is an acid or base, we use a chemical called an indicator, and in this experiment, we used a Cabbage juice indicator. pH scale is used to determine how acidic or basic a solution is. The more acidic it is, the lower the numbers. The less acidic it is, the higher the numbers. Neutral is generally around 7. If you really enjoyed this experiment, you might be interested in a career as a chemist or a chemical technician. And we'd love to see which solutions you try. Did all of your solutions come out to be acidic? Were some basic? Or did you have a variety of both? Send us your results. So it looks like we're coming to the end of our time. I hope you had fun, but before we go, it's time for your Find Your Einstein Funny. Are you ready? Where do chemists like to work on their experiments? In the basement. Get it? Like a base? All right, well, what's a chemist's favorite type of dog? A laboratory retriever? Well, that's it for today's episode of Find Your Einstein Friday. Follow me, Scientist Bond, Covalent Bond, as I share more wild and wacky science fun. And until next time, think like a proton and stay positive.